Welcome to the last talks of the series here at the IET at Sussex University. I did actually prepare a start slide, but then we had a little temperamental problem switching between computers. So I shall just talk to that, and then we'll introduce David, and he won't mess up with his slides. So you don't need to watch us try and solve that problem again, because it gets tedious. So as I say, this is the last talk of the season. We do have our new season starting in October later on this year, in the autumn. Our first talk is on connected vehicles on Tuesday the 3rd of October, 6:30 to 7 at the Hawth in Crawley. And Dan will be our speaker from Cisco for that talk that evening. And then, about 2 weeks later, we're back here in Sussex University again with a talk on artificial intelligence by Julie Weeds, who's a senior lecturer here at Sussex. And that again will be 6:30 to 7 in the lecture theatre, to be advised, here at Sussex. Okay, so that's the preamble for what we have coming up. The main event. As some of you will have noticed, we've been like good corporate citizens following the IET's theme of sustainability for the last season. And now we're going to do something completely different. And David will talk to us about steam engines. In particular, the Brighton Atlantic project, the final phase. And this talk will cover the reconstruction of an LBSCR Class H2 442. And perhaps David will tell us what that means. A steam engine at the Bluebell Railway using a boiler from a similar Great Northern Atlantic locomotive discovered in a factory in Maldon, in Essex. Okay. After many years of fundraising and construction, this new build is approaching completion, hopefully before the end of this year. And David, our speaker for tonight, is a member of the IMECI and has been involved with the Atlantic project from the beginning. He's also a director of the Maldon Locomotive Society and owns Pullman car number 36. So, with no more ado, I'll pass over to David.
Right, thank you very much.
And return for the Q&A afterwards.
Yeah. So we're going to have the lights down or what? Everyone happy with leaving the lights as they are?
Yeah. It'd be good if they dimmed, wouldn't it, really? We can see better what you're talking about.
Right. Okay. Anyway, I'm not quite sure if any of you have seen this talk before. So anyone who's seen it before? Or even seen the engine at Sheffield Park?
Yeah.
Yeah, okay. Well, the Class H2, which is this one of them, was built at Brighton Works, so just down the road. Now, a lot of our visitors to the Bluebell don't realise that there was a big works at Brighton, next to the station, where such engines as this were built. This particular one, the original Beachy Head, was built in 1910, but there were earlier ones, Class H1, this is an H2, H1, it looked similar, but the H1s were built at Kitsons of Leeds, so not at Brighton Works. There are 5 of those built, and there are 6 of these built, so not a very large number built. But they were based on the design from Doncaster Works by Ivert, H.A. Ivert, and he had an assistant called Douglas Earl Marsh, who eventually left Doncaster Works, came down to Brighton Works, where he took up the post of Chief Mechanical Engineer, and he found that the Brighton line was short of big engines. So he managed to get the drawings from Mr. Ivert and have these engines built to the same basic dimensions, which is why the boiler that we've got in Maldon can be used on a Brighton engine, even as a Great Northern boiler. So anyway, so we go through the background to it. So first of all, the engines, the H2s, when they first came out of Brighton Works, they were painted in this umber livery, which was Douglas Earl Marsh's favourite livery, and this is number 422. engines didn't have names at the time, they were just called numbers. So engine number 442, 422, there was 421 and 422, etc. and up to 424. Now because the Brighton loading gauge, that is the space around the engine, was more generous than some of the other lines, like South Eastern and Chatham, London South Western, when the grouping came in 1923, it was necessary to modify these engines so that they could go to the tunnels and the bridges on the lines down to the southwest and even to Dover. So before 1923 they were changed. So you probably won't notice the difference, but the chimney and the dome and the cab are lower now so that they don't hit the bridges, which is not a good idea. Anyway, this is number 422 again, and you notice now you've got 2 in front. That is because the Southern Railway numbered all these with an extra 2 for the Brighton area, so this is Brighton range. So this is number, and also they were given names. Headlands, like Beachy Head, North Foreland, South Foreland, Traverse Head, all around the south coast. So that's why the engine that we're reconstructing has to be lower so that it can fit under all the bridges and tunnels in the area. The last engine to run of this type was Beachy Head. This is the last one in April 1958 when it did a rail tour from London Victoria down to Newhaven. The reason it was put on that scheme was because that was one of the main routes for this type of engine, the Newhaven boat train. I came down to Newhaven. This is Newhaven sheds here. The sheds have now gone, but the other building over here is still in existence. So that's Beachy Head. RCTS, the organisation that organised it, was the Railway Correspondence and Travel Society, and they were able to acquire from British Railways one of the nameplates. It was on the side here, on the splashers, it says Beachy Head. So there, they got one of those, and the other one went to Eastbourne Council because Beachy Head, the cliff, was near Eastbourne. And then, of course, it was scrapped. There was a scheme to try and save it and preserve it as a last example of an Atlantic class locomotive, but unfortunately it wasn't successful, mainly because the accountants in British Railways wanted to take advantage of the scrap metal price, so they ordered all engines to be scrapped as soon as possible after withdrawal. So this is May 1958 when it was all cut up. It's been quite useful having these photographs, because some of the parts that we can't see on a normal photograph of a complete locomotive, can't see the detail, like these pipes here, so these are quite useful. They were taken by Mr. Best, who was one of the chaps who cut it all up at Eastleigh Works. Anyway, we now move forward 28 years, because that was the end of the Atlantics, non-preserved, apart from the Great Northern ones, which are now in Doncaster. Anyway, these boilers were discovered by a group called the Engine Shed Society. Yes, there was one. I don't think it still exists. And they were discovered at Maldon in Essex, being used to heat up a factory that made window frames, wooden window frames. They declined when PVC window frames came in, and eventually the firm was taken over by Bolton and Paul, and Bolton and Paul said, well, that's antiquated way of heating the factory. We're getting rid of all these boilers. So there's 4 of them there, and the one that we've got, we bought it, is this one here. That one was so bad that it was scrapped. The others are still in existence, the other 3. So consequently, the one that we bought was this one. It cost £12,772, and it was moved to Sheffield Park on the Bluebell Railway with the anticipation that one day we would build an engine around it. So here it is being loaded, ready to go to another company called Shipyard Services, who were going to take all the asbestos off. They were certified to do this. So it's just been lifted up to take away to Brighton Sea. Now we've done some research on the particular boiler that we found, and we found it's come from an engine number 3287. I haven't been able to find a photograph of 3287, so I'm afraid you'll start with 3286 and 3288. So this is in between those two. And it was withdrawn in October 1945, so bearing in mind that the boiler was actually made in 1941, it didn't have much use on a steam engine. So that's why it's in fairly good condition. We're also after a tender chassis, and fortunately the people that who are preserving Richmond, Manston, who are based at Richborough Power Station in Kent, had acquired this tender underframe which they were going to use with their engine. It's a Bullet Pacific Manston. Anyway, they eventually realised it wasn't really suitable, so they offered it to us for £750, the tender chassis. I knocked them down to 700, so eventually it was delivered in 1985 to Sheffield Park in order to form the basis of a new tender. This is a picture showing that particular underframe with the centre wheel set missing, so we had to replace these wheel sets. Don't take any notice of this on the top, it's a tank on the back of another building. It's not appearing on the top of the tender. They made the tender frame into a van for use at St Mary's depot over near Hastings. Anyway, so that was transported to Sheffield Park, and because it was all sort of more or less one that we could buy straight away, we were able to start on the restoration of that. Now, because we had no wheel centre in the set in the centre of the van, we were quite pleased to find that these wheels were available from the Royalty and Empire exhibition, which used to be at Windsor and Eton Station. It was a Madame Tussauds exhibition of Queen Victoria arriving at the station. And these were from a C2X tender, which was a London Brighton South Coast engine, so they're genuine Brighton wheels. And they were in quite good condition because they got fairly thick tyres on them, whereas the others on the original tender didn't. So because we had the tender chassis, we thought, well, we start on that straight away. And this is Fred Bailey, one of our team, cutting corroded parts away and replacing with new bits of steel. So although this was quite good, he managed to do quite a lot. We realised that doing this restoration or new build outside was a bit difficult because of the rain, and you had to put all the tools away each day and take them out next day. So we decided that it would be useful to have a building, a shed. So because the main works at Sheffield Park was always busy, so we couldn't use that. So therefore we had a new building, all the cost £80,000, I think it was, and we erected this in the yard. So here it is. We called it Atlantic House, which is still its name. It was a flat pack, so like IKEA, but a bit bigger. So this is the building. We erected it ourselves. We found it was rather flimsy. You could actually push the side and it would sort of go like a rhombus. But eventually, after we put all the struts inside, it became fairly rigid. We learned afterwards that it was actually built in Australia, so I think probably it should have been upside down. So we put a pad, concrete pad with two sets of rails on in order to accommodate the building and also allow us to put the locomotive inside and also the tender on that side. And here is the official opening of that building, 2006, and this is Richard Gibbon, who was the head of engineering at the National Railway Museum at the time. He was quite supportive, but you notice that I'm being handed this regulator handle. This is a chap called Mr. Wiseman, who after Beachy Head in 1958 was scrapped. He was so keen on this engine, he was able to persuade British Railways to sell him this regulator handle for 5 shillings, and he had it in his garage for some years. Eventually he decided he would present it to us as a part of the original Beachy Head. So from then on, of course, we weren't building a new engine at all. we're restoring the original. The other thing we needed to do was to get lots of drawings. Assembly drawings were always available from Oxford Publishing. They had the archive, but we needed detailed drawings so that we could make the parts for this engine. So consequently, we were given the nod. The National Railway Museum had a whole basement full of drawings which they'd inherited from Eastleigh Works, from Ashley Works and Brighton Works. So a team of our group went up there, I think about 3 times a year, to sort all through the drawings, getting very dusty because they were just laying in the basement. And in exchange for us cataloguing those drawings, we were able to have copies. So sometimes the copies weren't really much use to us. Fred Bailey, who you saw earlier, was a skilled draftsman, and he's converted them all to CAD. So most of the drawings that we use these days are from the CAD. So one such drawing that we got was the pipework drawing for the pipes in the boiler. So this is a section through the boiler showing the various lubrication pipes, the steam pipes, the vacuum pipes, and all that, which has been quite useful to make it accurate. The other thing we did, we have a number of supporters. I think I've got about 550 at the moment, supporters of the Atlantic project. We send a newsletter out twice a year, and in the newsletter we tell them about things that we'd like sponsorship of. So we did this on this particular occasion, mainframes, headframes, all sorts of things, and priced them all up. But interestingly, most of the smaller parts didn't go very quickly. The bigger parts, like the mainframe here, that was 2,500, I think, estimated, and that went very quickly because some of our supporters were not short of money, and they wanted to have a major part so they could point to it in the future, saying, that's my bit of engine. This strengthening plate here, by the way, was had, because it's a bit narrow there. So the design was that it would strengthen the narrow part to stop it bending. And here was Keith Sturt, one of the project manager, who is putting in one of the hot rivets with the hydraulic caliper. So we have the hydraulic calipers, unless we can't get to it, then we use the air gun to actually get the rivet done. This is inside Atlantic H2. You can see the advantages of having a dedicated building. And then all our supporters who sponsor things get a rather smart certificate. This is number 379. I think I'm up to about 800 now, certificates for different parts. And this gentleman, Tobias, was one of our overseas supporters. We have quite a number of overseas supporters, and he's from Sweden. So each year in June we have an open day, so that the supporters can come in and see what's happening, and hopefully bring their checkbooks with them, and sort of sponsor a few more parts. The nameplate here, by the way, Vichy Head, that's a replica. You would never put the original on because they're worth about £20,000. So we have replicas for use on the engine when it's in service. 1st of October 2007 was quite an auspicious day. That's when the frames were erected with the cross pieces, and that is when the locomotive actually exists. In the past, when the locomotive was being produced, say at Brighton Works down the road, once the frames were on site and tied together with their supports, that's when the locomotive actually came into existence. So our replica Vichy Head started live 1st of October 2007. And then we had to start riveting it all together. Initially we bolted it, as you can see here, but then put the hot rivets in afterwards. And this is the using the air-operated rivet device. And here is one of our members. This is actually Neville, who's our newsletter editor, holding a stay here to stop the rivet going through. That's when it bunches up. Well, I said to Neville, how do you know that's you? And he said, well, I recognise the stomach. So eventually it all got tied together, ready to put all the axle boxes on, sand boxes and all the other bits and pieces that we were making in conjunction with the works. Now there was two items which we weren't too happy with to reproduce. One of them was the main cylinders. There's a cylinder inside, of course it's a two-cylinder engine, and this is a plan view with the piston up the top here and the valve here. And it was a huge casting, very complicated casting, which we felt if we could find someone who could make it, it would be very expensive. So Fred Bailey, our design engineer, decided to go to the American practice, which was fabrication, rather than the casting. So he came up with a design which consisted of 3 parts instead of the 2. The outer cylinders here and the valve chest in the middle as a combined valve chest. So this was all welded together. Obviously when you weld something it produces a lot of stress, so consequently we wanted someone to normalise it afterwards, and fortunately Ricardo's came up with the offer to normalise it in their big furnace. So that was raising the temperature up to 630 degrees C and then let it cool very gradually. I think it was about 2 days to let it cool, and that would relieve all the stresses in there. And then eventually it was all ready to go into the gap between the trains. We were given this overhead crane here, that's a pillar frame from a factory that was closing down, and so that would be quite useful over the years to lower things into place. Over here you see one of the patterns from the bogie wheels. So all the wheels were newly cast in Sheffield, and the patterns were made at Sheffield Park by a pattern shop at the Bluebell Railway. And this is a view looking down on the top of the engine at the time. So this would be about 2010, I think. So the big cylinders inside, one side, one the other. The valve chest in the middle, and various fittings, including these pipes here. That was a vacuum pipe, and that's the air pipe. Because the London, Brighton and South Coast Railway used air for braking, whereas most other railways use vacuum. So on this engine we have to have both, because we need air for the braking on the engine, but we need vacuum to brake the carriages that you're pulling. So you can see it's getting rather full of stuff here. These shells were empty when we fitted them, but as usual they get to a couple of bits which might become useful. So once the cylinders are attached to the side, we then have to do a hydraulic test to make sure there's no leaks. So everything is blanked off, and then we do the hydraulic test. Do the same with the boiler later on. Now the other thing I mentioned, there was 2 items that we weren't too happy to reproduce. One was the cylinders, and the other was the connecting rods and the coupling rods. Now there was various companies in this country in the past, like Hesketh at Bury. There was also a company called Anderson Brothers at Coatbridge up near Glasgow. They did the ones for the Q class on the Bluebell, and Hesketh did the ones for the U class, 1638. So we needed new connecting rods and new coupling rods. So as these companies went out of business, there was no one left to do it. We did have an offer from an Indian company in, I forgot where it was in India, but they offered to produce these forgings for us. But the main problem was they couldn't give us a traceable trace on the material. They just said it was best steel. Which of course, if you look at the original spec of the original Atlantics, that's what it said, best Sheffield steel. So I weren't far out. we needed a number, like an EN number, to make sure that we had traceability of the material. So eventually we decided to buy some forgings, they were blanks, just pieces of metal from a firm in Rotherham where there was a traceable back to the original manufacturer, and so we used these in order to make the connecting rods and the coupling rods but we had to make it the right shape. So we did it by water jet cutting. So this is the blank here, and this is the water jet, 60,000 psi, goes to anything, including the steel, and we cut out the various parts. But you still have to machine them afterwards, of course. So we sent it up into a firm in the Midlands who were able to machine the flutes and the holes for the bearing. So they came back from there, all fully machined, as you can see here. These are resting on top of the tender, chassis just for storage space. So all the flutes were done. We had to linish them afterwards because the water jet cutting can't do a long trace along the side there. It has to come up and down again. The bogie was manufactured in 2012, these are the wheels that were made from those patterns that you saw earlier, and this would have been a casting here, but we made it as a fabrication again due to cost restraints. But later on, as money came more readily available, we changed that. We threw this one away, the actual chassis here, and made a casting instead. So it's now got a casting as per the original design. The bogie has to twist underneath the engine to follow the curves, of course, as it goes down the corner. So now we're getting nearer completion, well, of the chassis anyway. We're leaving the boiler till last. You always leave the boiler till last because once you've tested it, it starts ticking on the boiler certificate. So this is looking down on the front. You can see the pipes here and the valves and things like that, and the saddle. This is a smoke box saddle where the front of the boiler goes on. Again, that would have been a casting, but it's now a fabrication. And then all the valve mechanism has to be assembled. So things are made. One or two of these items were made in the West Midlands, in Birmingham, but most of the other items were produced by local companies, including a firm in Storrington, which a lot of people were surprised at, but companies are around if you can find them. These are the valves here on the end of this rod, and the valve, of course, has to be set properly to get the right action of the steam entry and the exhaust. So Fred made up this design of what is basically a big nut, and you can turn this round, and that either expands or contracts the length of the shaft, which goes to the cylinders here to get the right action of the valve timing. It's quite clever because it hasn't got a left-hand thread and a right-hand thread. It's got two right-hand threads, but they're different pitches. So when you turn this round, you're making the shaft longer or shorter. So you can't see this now, up inside the engine. And then we had the crossheads had to be made. These were made by a company in the West Midlands again, in Southport. They were actually free because we had another machining job done by them which wasn't satisfactory, so we made a complaint and they sent their managing director down, and he said, oh yeah, I can see they're not right. What can we do to rectify this, or how they're making crossheads but not charging? So that's what they did. So these are actually free of charge. So they move up and down the slide bars here to rotate the wheels. So then we had to think about lifting the engine up in order to put the big wheels underneath, the big driving wheels. They're 6 foot 7.5 inches diameter, so you need a fair amount of height. You can buy jacks which would lift this engine up. They use them up in carriage and wagon to lift up the hooded carriages, but we didn't have enough space in the Atlantic House. Would have been better to have a bigger building, of course. So Fred designed this device here to make sure that we could lift the engine and run the wheels underneath. So while the engine was up in the air, Pete Stewart, who's an ex-gas fitter, used to work for South Eastern Gas Board, done all the extra pipe work, various cylinders here, This is an air cylinder for the air brakes, and so these were all fitted up ready for when it can come down again. And then this is the Stevenson valve mechanism inside the frames, with all the pipe work involved as well. Some of it was quite tricky to fit in because it was a bit limited space. I've got to watch the time because it's a bit limited by time. I did this talk last night by the way at Southwick, and they wanted it to be not more than 2 hours. So this one's going to be a bit quicker. So the driving wheels came in October 2013. These are, as I mentioned before, 6 foot 7.5 inches diameter. They were cast in Sheffield and the tyres were fitted in Berry, company in Berry. So we had to run the bogie out in order to lift these riding wheels in. Callum, one of our volunteers, one of our younger volunteers, most of their volunteers are fairly ancient, so he did all the painting ready to lift the frames up in order to run the wheels under. And here's the wheels with making sure they timing was right by this device, which is like a roller device to turn the wheels around in increments in order to make sure it's all level. And here is the actual eccentric underneath, piano wire, making sure that it's all level with the spirit level there to make sure it sort of has the timing right. Rather splendid idea here. We use Heinz baked bean tins with oil in them as a shock absorber, so they wouldn't wave around too much. And then this is the day when the chassis was lowered down onto the wheels, 2014. Seems a long time ago now, but it takes a long time in these projects. And here's a very rare picture of me doing some work on the engine, putting the piston in. There's one of these pistons each side. I've got 3 rings, 3 piston rings, to make sure that it slides properly. So that is the fitting of the pistons. And then we had to start putting the covers on, fabricating various parts, sheet metal to cover up various parts that need covering up. Now you might think it's a bit premature to do the lining, but we wanted to impress our supporters who came along with their checkbooks to show that we were getting on quite well and have had some more money. Because it's cost, the total cost so far at this time was about £1 million that we spent on this engine. So Tony's lining out the side of the balance here in BR colours. It's going to be in British Railways livery, although it can be in southern green or either malachite or olive. But initially it's going to be in British Railways livery. And here's one of our open days. I'm just demonstrating one of these fittings here to the assembled multitude, and so they can see what we're up to. And then here's Neville again with his linisher. We're just finishing off the connecting rod before we assemble it onto the side of the engine. Now some of the castings these days, because most of the castings in the early start of the build were made from the wooden patterns as normal, but latterly the idea of using polystyrene patterns has become more popular. So these steps here are made from the polystyrene pattern. The problem is, of course, the polystyrene pattern melts away with the molten steel going in, and so you have to make a new polystyrene pattern. Whereas with a wooden pattern, you take it and use it again. But with a small item like that, it's not too much of a problem, especially as it's much cheaper than a wooden pattern. And then the dome of the boiler, we started work on the boiler latterly, and this is obtaining a good metal to metal seal here. Various bits and pieces going inside, because when we bought it from Maldon in Essex, a lot of the interior was removed for its use in the window tray factory. The bottom of the boiler is called a foundation ring here, and this gets fairly corroded due to all the plug going down between the outer and inner firelocks. So we had to replace some of the metal with new plate. And this is James, one of their full-time staff actually in the Bluebell Railway, cutting them out ready to put new pieces in. And here's the new piece being welded in by a chap from Brighton, who was a coded welder. Although we've got people who can weld, they don't have the necessary piece of paper to say that they're coded welders. The problem with this chap is he comes from Glasgow and we couldn't really understand what he was saying. And I don't think he could understand what we were saying either. The other difficulty was that he only drank coffee and we only had tea in there. We had to buy some jars of coffee and special thing in. But he was very, very good, skilled craftsman. All the tubes are new, of course, because the boiler didn't have any tube in, because they didn't need them when it was used at the factory. So these are the big tubes, made in Oldbury in the West Midlands. We've got big tubes for the superheater elements and the small tube, which we call the smoke tubes. So there's 32 of the big ones and 120 odd of the small ones. So these have just been delivered. Pieces driving the forklift truck, and Freddy's having a look at them thinking, oh crap, we're going to put them all in now. So here's all the holes ready for the tubes to go in. And the superheater element header goes up here. Inside the boiler we had to make a new casting here from a pattern, and this was made at a company in Crewe, I think, something like that, for the regulator handle. And then we had a bit of difficulty getting the superheater header made, very complicated piece of kit, because it has lots of different ports inside which enable the steam to go in and out. And so eventually this was made using a polystyrene pattern, because it was much quicker to do. And fortunately a company up in Smethwick called Premier Castings, who managed to do this, but also machine it, as you can see, and do the hydraulic test, all for £7,800. So that was quite good. So that is now on the boiler, ready to run and steam it. The other company that we used, or a local company, was a company called EPAL in Storrington, and they made all these handrail fittings. As you can see, there's different varieties of handrail fittings, depending on where it's got to go. Some have got threads, some haven't, some are blind, some are open. So there's all these sorts of things. And these are the ones for the handrail. Goes along the side of the boiler, so when the fireman or the glider goes along to lubricate, or oil up as they called it, you could hang on to something. So we got to the stage, we put the replica nameplate on to show people what one it was, and then we now started putting, at this stage, putting the cab roof on and the cab sides. Originally we used to just put a ladder up and go up there, but no, you can't do that now. You have to have scaffolding, but not only do you have to have scaffolding, you've got to have a certificate to show that you can put the scaffolding up due to all these health and safety regulations. And then the roof itself was made using sheet metal and these fairly small rivets, so you don't need to heat them up because they're quite small to put the roof on. And then the roof is fitted on the top here, and various fittings can be added until the boiler goes in. Once the boiler goes in, then you've got a lot more work to do. So the boiler was eventually tubed, so all the tubes going in the boiler. Fortunately the tender was behind the boiler, so we could pile all these tubes up and then sort of post them through the holes, and then expand them. They're expanded in the holes at the other end. We had to make them the right length. We ordered them too long, deliberately, so we could cut them to the right length to fit them in to suit the distance between the front tube plate and the firebox. So we bought this bandsaw for trimming the tubes to length. And then we have to expand them, of course, to make a watertight seal, because we're going to go up 170 psi in this boiler. So here is fed with the expander. Here, good exercise. We offered courses in exercise here, cheaper than going to the gym. We had one or two people who came. After a few hours, they gave up. And of course, it quite often broke because of such a force to expand the tubes. And Mr. Marsh, we complimented Douglas L. Marsh on the design because the tubes, big tubes, are big enough to put a mug of coffee in. And then the foundation down the bottom, we replaced all the rivets just to make sure. And this is Simon, one of the full-time staff at the Bluebell, with the hot rivet going in and the air gun here to clean it over. And here's all the rivets finished off. Foundation. So we're now at August 2017. And then, of course, by this stage it's necessary to take it outside to do the hydraulic test. At the same time, we're making the Ramsbottom safety valves. These are new casting, of course, and Tony is in the main works at Sheffield Park Machine and Meg, ready to go on top of the boiler, which is, here it is on top of the boiler. So all the back head here has been blanked off, ready to put water in and pump it up for the hydraulic test. But to do that, as I say, we took it outside rather than do it in the works, as if there's a big leak, we get a flood. So we carried on with that. Here it is being towed out. We jacked it up and put it on these wheels in order to pull it out and put it outside here. That's a harbour crane, of course, quite heavy, this boiler. So now in 2018, putting the boiler outside in order to pump it up, do the hydraulic test. So here it is. I made up a wooden number plate to put on there so people knew which boiler it was. So bully people featured it. And of course there's an ash pan underneath to collect all the ash, but you can't put that on until more or less the last minute, because it won't sit on the ground properly with the ash pan. We also needed some pressings for the washout plugs. We had a bit of difficulty finding any company in this country who could make these. We eventually found a company in Coventry who was more well known for making the Olympic torches in 2012. So they had skills that could bend metal and shape them. So they made all these. In fact, their apprentices made these shapes specifically. They were given this job. And then the apprentices came down from Coventry to see what their bits were going to be used on. And so we showed them where the bits were being used. So the washout plug at the bottom. And this is the boiler, and this is the external cladding, with the gap between, which is eventually going to be filled with insulation. Of course, in the old days, they used asbestos. The other thing we had a bit of difficulty in getting anyone to make was the dome cover. Eventually, we found a company who could do it, but they wouldn't have been able to make it in steel. So we said, well, it's going to be painted anyway. You can make it in aluminium. So they were able to do that with the machinery that they had, make an aluminium dome cover. And in line with their idea of getting people to sponsor things, this was sponsored by a lady called Anthea, this lady here, and she sponsored it on behalf of a brother, Graham Mallinson, who was one of the 11 men who were killed at the Shoremare crash. So some of the parts on the engine are in his memory. And then it's painted the campsite again. You might wonder why we've done it so early. This was to impress the supporters at the open weekend, so that they would start thinking about putting some more money into the scheme. And then we had quite a good reaction from Bachmann. Bachmann are model makers, German company, and they made a model of Beachy Head with our help, supplying the drawings, and they sold 4,247 of these, and they said they would give us £2.50 for each model. So that worked out £10,617. So this is Richard Dragoman from Brighton presenting us with the cheque for that net. So that's quite good that we had this extra funding. This is one of the models. It's on show at the Maldon Model Railway exhibition at the NEC, National Exhibition Centre, and they sold quite well. I think we've still got probably one left in the Bluebell shop. And then one of the last pieces we had to get made was the tender tank. We already had the tender chassis, as you saw earlier. So the tender tank, Fred Bailey did his CAD design for it, and then we passed the information on to Birmingham Roster, who were able to manufacture the tender tank. All these are baffles which are necessary in the tender to stop the water sloshing around, and also to hold the sides in when you get all the water in there, 3,000 odd gallons. It's going to try and push the sides out. So that's the tender under construction, the tender tank, and here it is arriving at Sheffield Park in 2019. Just been lifted off the thing. And then by now, October 2019, we were ready to do the hydraulic test on the boiler. The boiler pressure is 170 psi at the test pressure, but we obviously have to pump it up higher than that, 233 psi hydraulically. So we did this. This is the boiler inspector. So he is the person who tells us whether it's okay or not. And as you can see, he's quite happy because it's passed. So we haven't done a steam test yet. That'll be later. But we did the hydraulic test at this stage. And then the final pass of the tender chassis, company in Gloucester only made the basic tender tank. We had to fit all the other fittings on, like the doors and the cab floor and all things like that. It's a wooden floor made of Iroko wood, very hard wearing, so that the heavy feet of the fireman and the driver don't wear it off too much. And then in the tender tank itself, there's these filters which stop any muck going into the injectors, which doesn't do the injectors any good. And then doors were fitted on the tender. This is the original underframe that you saw that we bought from the Manston people. And then we have the crest to go on. So there was only the early British Railways crest used on the Atlantics because they'd all been scrapped before the new design came into existence. So this is the original beachy head on a service train going through Kensington, Olympia. We had a fairly close shave here because we found that the firm that made these transfers that we wanted were just about to close. So I managed to buy some of these for putting on the tender. I was told about it because the fellow member of the Pullman Society realised that I would need some coats of arms for my Pullman car, and he said, "Oh, did you know that Turns were going out of business?" Oh no, so I contacted them, managed to buy a complete set for the Pullman car and also one or two for the engines. So this is the superheater header in place, bolted in place on the plugs of the boiler before the smoke box goes on, and then the superheater elements have to go on here and push into the big tubes. So here's the superheater elements manufactured by a company that's specialised in this sort of thing. That was 2019. They go up and down. It's a superheat to steam. Some of the early engines, of course, didn't have superheat, but the Atlantics did. And here they are in place, looking inside the smoke box. You have to slightly adjust them, as you can see, heating them up to make sure they go in properly. And then, of course, the final part before the boiler goes into the frames is putting all the cladding on. Now, in some cases, you put the cladding on afterwards, but we decided it would be better to put the cladding on first and then devise a system whereby we can lift the boiler using fitting on the top of the dome and also on the top of the safety valve, so we could lift it up and position the frames. The before that, Maldon is here putting the final parts of the cladding on. This is all outside, of course, and various fittings down inside. Again, these were made by the same company that made these items there. So everything was nearly ready. Fred was a bit concerned with these cutouts here, whether they would fail the splashers for the wheels. And this is the insulation. As I say, in the old days they used to use asbestos. Obviously you can't use that anymore. So we buy this material from Maldonite, which is a ceramic-based material to provide the insulation for the boiler. And then came the day when we were going to be lifting the boiler into the frames, and of course you have to pull the engine out first in order to do that with a big crane. So we had to build what we call the Western extension, not the one that goes to Harvard. This is just the Western extension coming out of the landing house. And to pull out the engine, we bought one of these winches that normally used on the front end of a Land Rover, and the battery operated, so we had a big battery. And we could pull out the engine and then put the boiler in using the big crane. Now here's the big crane, customs crane. As usual, when we're doing this sort of thing, it rains hard. Pouring with rain all the time. So fortunately, we're hard hats on, not to stop the rain, but to stop the engine bashing your head before it drops. So this is August the 16th last year, when the boiler was fitted into the frames. So we pulled the engine out, lift the boiler up, put the ash pan on, and then turn it round and lower it into place onto the frames. So this was all done in some secrecy. The trouble is, if you announce that you're going to put the boiler into an engine, you get hundreds of glycers coming to take photographs, so we don't tell anyone. Just keep it to ourselves. So that is going down into the frames, and then this is it, already in the frames, with just the cab roof being put on. We had to take the cab roof off, of course, in order to put the boiler in. So this is the customs frame here. While all this was going on, Tony decided he didn't want to get involved with putting the boiler in. He carried on with his lining on the tender. So this is the tender being lined out in British Railways design, and here it is, more or less finished now, with the crest on. You can get two types of these. You can either get the self-adhesive crest, where you peel off the back and stick it on, or you can get the one which is done with varnish. We prefer the varnish one because if you stick the one on with self-adhesive and you get it wrong, you can't take it off again without removing all the paint. So we use the varnish method, so you slide it all around, make sure it's level and in the right place. And then once the boiler's in, of course, we can then do all the pipe work in the cab. So this is an early photograph, original photograph of H2, showing some of the fittings, including the bar-hole door, and gauge glasses, and all the fittings here, the seats. And this is our engine with some of the fittings fitted on. The BBC wanted to take a film of this, so that's why this chap here with his big camera. He was actually interviewing Anthony Maldon, the son of Graham Maldon, and they wanted me to explain what we were doing. So we had quite a good time there telling the BBC what we were doing. But that was the interview. So we closed the smoke hole store here, but when you opened it, there's new bits of pipe in there to complete the actual pipe work. And then there's more pipe work on the back, scaffolding again, in order to get to the top. We've still got to paint the inside of the cab and also put all the lubrication pipes in from this hydrostatic lubricator. There's a seat there for the fireman. The driver has got a bit of an uncomfortable seat actually, and then there's the wooden floor here. And you wouldn't normally see all this because the tender would be in the way. This is the tender's away at the moment. And these are the main steam pipes in the boiler. They were made by Henry Mofort, one of our full-time staff in the main works. once they're in, they have to be taken out again, do a hydraulic test, and then everything was satisfactory. So we was able to think about the next stage, which is still ongoing actually at the moment. We haven't quite finished it yet. Various pipes along the outside. This is the pipe. This is the pipe from the brake ejector, and here is one of those handrail supports you can see there. And the handrail has got a dual purpose. One is to hang on, being a handrail, but inside the tube is a valve arrangement for the Westinghouse pump and also for the blower. The blower is the thing that grabs the draft when you're lighting up in the morning to get the steam raised. So that's on the other side. This one is for the Westinghouse pump. And then finally we had to think about castings for the number. The wooden one wouldn't have been any use, so we had the new castings made ready to go onto the front of the engine. And this is a painting by Matthew Cousins of Beachy Head that was finished, and we nearly finished. when it's finished, it may not point this way, it may point the other way. And this is on the Santa special, because every year we have a Christmas card produced. This was in 2002. So this was the first one, showing Beachy Head completed and coming out of Horsted Cane Station on the way down to Sheffield Park. There's been various Christmas cards over the years in different liveries, umber, malachite, olive green, the art colours, not only on the blue, depicting it on the Bluebell, but in coming through Lewis, coming through Kew Junction and all sorts of other places. But these are quite popular. They more or less sell out Christmas cards. So hopefully that's given you a bit of a story about how we're getting on with Beachy Head. Should be finished at the end of this year and then into service sometime next year, provided nothing untoward happens. But if you want to know more about the Atlantics, the design and the background, various books have been published, including this one by James Baldwin called The Brighton Atlantics, unusually, and on the front there's a malachite green engine. There's also another book which was produced locally by Jeremy English, and that's quite interesting because it's got lots of things about Brighton works as well as the actual engines. So there we are.
Really interesting talk, not just in engineering heritage, but from my point of view, such an achievement, putting it together as a voluntary organisation, a project of that size. Really, really interesting. Are there any questions?
We know that it's taken you a long time to build this locomotive for quite obvious reasons, I think. But if you were down in the Brighton works in the years when they were building one, how long would they take to build one?
About a year. Because they had a lot of people and they had all the parts to hand. Yeah. And normally it would take a year to build an engine like this. It would take a bit longer.
As a new build, is it to mainline standards?
No. Well, it is the mainline standards, but we haven't got any certificates for it, because that would cost quite a bit of money. And anyway, there's no guarantee that mainline running will continue in the future. I was told yesterday, because I gave this talk yesterday to the Southern Electric Group, and I was told that the authorities in Belgium have now banned, or will be banning, mainline steam. So it could be the start of a trend around the whole of Europe.
But we've left Europe.
Yeah, you explained that you first fabricated a bogie and then decided to cast one after all.
Yes.
Was there an engineering reason for that, or was it just to be more authentic?
No, it was a cost reason. So the fabrication was done because it was cheaper.
Yeah.
But then we realised that would be useful in that particular part to have a cast as per the original design.
Yeah.
So that's why we changed it. We still got the fabricated bit. Don't know what we're going to do with it, but it's still
There's another one.
Sheffield Park Yard.
presumably those main wheel sets had to be balanced. Obviously not a case of just clipping on some lead weights.
No.
How do they do that?
Well, it's part of the casting. So it's all calculated from the drawings. In fact, two of the wheels are different from the other wheels. Because the two rear wheels have got to balance the connecting rod and the coupling rod. Whereas the front wheels have only got to balance the coupling rod, or the front end of the coupling rod. Yeah.
It's all done by calculation.
Yes, from the drawings. Yeah.
Any other questions?
Yeah, given it's a new build, every part has been manufactured from you.
Yes.
If you use the original standards, whether that be Whitworth or what you take opportunities to go metric?
No, we kept everything imperial.
Okay.
So the whole lot is inches.
Yeah.
The only thing that's different on that is some of the metal, instead of being 25.4 inches, 25.4 millimetres, is 25 millimetres. So we've had to adjust slightly in order to compensate for that on the frames.
Wondering if you're not going to run it mainline, will you do your own certification, and what line speed will you be running?
Oh yes, it's being checked all the time by what is called an independent competent person,
Right.
who is from another railway. So he's independent of the Bluebell from another steam railway, who's a skilled engineer who can check everything that we're doing. We also have a fairly thick bundle now of certificates and test items for all the parts, like the casting, things like that. So it's all regulated from the ORR, Office of Rail and Road.
Sort of an addendum to the first question. Do you know how much it costs, the first engine? Built at Brighton Works, the first Atlantic.
Oh, the first Atlantic at
Yeah.
Brighton Works, no idea.
Because
I know much less.
it is just amazing. I heard a story, I don't know whether it's correct, but an LMS Jubilee called Southern Rhodesia, the nameplate was sold for more than the cost of the engine.
Oh yeah.
I mean,
That's fairly normal.
and I think they were said to cost about £6,000 in the 1930s.
Yes,
when
yeah.
it was built.
That'd
So
be
I just
about
wondered-
right. Yeah. Well, the nameplates we've got on here are replicas,
Yeah.
but the original ones,
As you said, it's worth a fortune.
yeah, they're about 20,000 they're worth.
Yeah.
But one of the original ones, is in building up on Beachy Head itself, near Eastbourne,
Yeah.
called the Beachy Head Centre, and the other one's in our museum on platform 2 at
Okay.
Sheffield Park.
Yeah.
And that's the one that's owned by the RCTS,
Yeah.
so it's on the loan to us.
Yeah. No, it's just amazing, some of this memory.
Oh yeah.
Any other questions?
David, apart from the drawings, have you had any other contact with the National Railway Museum?
Oh yes, yeah, through Richard Gibbon. Richard Gibbon, he hasn't been down lately. I think he had a stroke, but he used to come down every year on our June open days and give us some advice and have a look, see what we were doing. Yeah. So yeah, we contact with the Railway Museum. Of course, when we did the drawing search in the archive then in the basement, we had to be vetted to make sure we were allowed in the archive. So we had to sort of take an exam or whatever. I never got involved with that. That was all done by Fred and Keith and Roger Cruz and other people from the Bluebell. I could have done it if I had the time, but I was working where some of these other people retired, so they got plenty of time. So, allegedly.
Did you say the southern region had 6, was it? 5?
Well, I had 11 altogether. I had
11.
6 of these,
Yeah.
H2s,
Yeah.
and 5 of the early design.
Okay.
The main difference being the running plate. On the running plate, which goes along the side of the engine,
Yeah.
it used to be undulating on the H1.
Okay.
So that's, if you see a picture of an H1, that's
Yeah.
how you can identify it.
Now,
That was based on the Great Northern drawing.
I was going to say, how did they differ from the Great Northern ones?
Well, not a lot. That's why we can use the boiler.
Okay.
Yeah.
And how many Great Northern ones were there? You know?
Oh, about 90.
So took many
Because
times. I know they used to run the mainline trains in
Yeah, they used to
King's
run
Cross
on the
before
mainline.
the
Yeah.
Pacifics, yeah.
King's Cross up to Aberdeen.
Yeah.
Yeah.
And I didn't realise though that the original design was from a manufacturer was in Leeds.
Only for that first batch of 5.
We,
They were done by Kitsons
yeah, yeah.
for the LBSCR.
Yeah, but that's for the first ones on the Northern, Great Northern.
Oh, the Great Northern, they were made at Doncaster.
Oh, they were all
In the
made
plant,
at
yeah.
Oh, okay. Yeah, I see what you mean. You're talking about first batch
Sort
of
of
5.
yeah, the first batch of 5.
Yeah,
Yeah.
yeah, okay.
Yeah, if you go, anyone who's interested, you go to Doncaster,
Yeah.
the new Dagenham Gallery, which is only opened, what, 2 or 3 years ago. They've got the Atlantic in there,
Yeah.
and also Green Arrow.
Yeah.
One of the other engines built at Doncaster.
The Green Arrow, you could say.
Yeah.
2XL, yeah.
Yeah.
Okay.
Is there an operational service plan already coming together about where it's, will it be solid on the Bluebell, or will you be hiring it out? Or?
Initially, it's only going to run on the Bluebell, so we can get the advantage of a new engine running on the Bluebell. We've had about 4 inquiries from other heritage railways who want to hire it. Well, I think one of them wanted to borrow it. It was slightly different. I had an email about 2 weeks ago saying, can we be the first in the queue to borrow your engine? No, replied saying, come back to me in 5 years' time and we'll have a look into it. Yeah.
And do you shift them around like we see on Channel 27 on these huge trucks?
Well, we're not intending to do that because it does give a bit of a strain to the frames, running up a slope onto the low loader. So we prefer it to go by rail, like the Camelot.
I was going to say that. Why can't they be towed by a diesel locomotive, say?
So they can, but it's probably going to be expensive, more expensive than the low loader. The lady over there was asked a question.
I don't have a question, but I just have a comment. So I'm really impressed by your team. So I thought, because HS2 has so much problem now, a lot of problems. So can you put your team to help?
We finish next week.
Yeah, the budget. The trouble is we're not civil engineers. We're mechanical engineers. We're not even electrical engineers. Because people say, well, if it goes on the main line, you've got to have all these gizmos on. But you know, the TWPS and all the others. But you need electricity for that, which we don't have on the engine without putting some sort of generator on.
So then you can help Siemens.
Yeah.
So on manufacturer side.
Yeah.
If I understand correctly, you haven't run the steam through it yet.
No, we haven't done the steam yet, no.
Will that be done in secret as well? Because I imagine
Probably,
there'll be a few tears on that day. Happy tears, I'm sure.
Yeah, we probably won't be telling anyone. Now, the first thing you'll know is a report in the press saying they've done a steam test and it passed. Hopefully. Yeah, Fred Bailey, when he was doing the cylinders, the new cylinders, he put some chalk marks in so that the steam would know where it went. But I did point out that the steam will probably erode this chalk mark, so you won't be able to see where it's going anyway.
So there'll be a puff of chalk out the top first time.
Yeah, so if you see white smoke coming out, it's
So you mentioned you had to reduce the height of the dome and the chimney.
Yeah.
Is there a functional disadvantage to do that?
not really, it was only very slight. It was just to miss the bridges. Yeah, sometimes when you reduce the height of the chimney, it does affect the draft, but it's not sufficient on this design.
So, last question.
Just one last one, if I may. Did you, in your research for the construction, did you find any sort of failures that you had to rectify from the original construction of the steam engine?
Right, yeah. We didn't actually. I know Tornado people did on their Class A1. The only thing we found was that the far hole door when you want to shut the fire hole door, there's a ratchet arrangement. So you open the fire hole door and the ratchet holds it in place. So the fireman, when he throws a coal in, it won't come back at him by hitting the fire hole door. And we found this fire hole door used to, for no apparent reason, close. And it's the same design as on Tornado. So when the Tornado people came down, because we get lots of visits from other people building new engines, when the Tornado people came down, we said, well, do you have a problem with your fire hole door? It's the same design as we've got, Great Northern design. It keeps shutting. He said, oh, he said, well, have you worked to the drawing? He said, oh yes. Ah, that's where you went wrong. Because Doncaster Works people who built these fire hole doors knew there was a problem with the ratchet catching. So they always modified it, but it was never put on the drawing. So they knew that. So having got the information from the Tornado group, what's his name there, whoever does it, we modify their design and it works all right now. Fire hole door stays open. So that's the only thing which could fall into that category.
So your anticipation of the highest steam pressure, does that relate to exactly what was originally conceived?
No, the steam pressure is slightly lower. It's 170 we're using, but originally it was 200 on the first ones. Then they reduced it later on when they didn't need that amount of power. So we keep to 170. So the hydraulic test was 233, which is based on a formula 1¼ times plus 10 to give the hydraulic test.
And how fast would it be able to go?
25 miles an hour. That is the limit on a what's called a light railway, which the Bluebell is. Yeah. I mean, records show that Beachy Head did get to 90 miles an hour on the main line.
In terms of, obviously you've built new and you've built all of the parts, have you also built spares as you've gone along? Sometimes it's easier and cheaper to build a number of parts at the same time.
No, we ordered a complete new set of springs, a spare set of springs, because they eventually go, and then there's our parts we made as well. Yeah. We're fairly well off for funding, because people, especially now, when people can see the end, they seem to give us a bit of extra money.
Anything else? Dave, sounds like we are wrapping up.
There. Yeah,
thank you very much. We'd like to present you with a very small gift, a small certificate. To say thank you very much, and great talk. Thank you very much.
Thanks very much, Greg.